Okay, bit of delay due to all the new students coming in, but let's get ready to do some chemistry. So we're getting into chemistry, and it's basically the branch of science that deals with identifying and understanding all of matter and what it's composed of around us. Why is it important? Well, even on a basic level, it's important. And to answer that best, I have a little story from my high school days when I worked in a Subway sandwich shop, and this guy didn't understand the importance of not mixing the glass cleaner with the toilet cleaner and ended up shutting down the entire building because he accidentally made ammonium chloride. It's a common mistake, but if you don't understand how certain things combine, then it's one of those things that can lead to some very serious and possibly deadly side effects, as ammonium chloride can kill people in strong enough concentration. Luckily, nobody got hurt then. We need to start with absolute basics, so we're going to start with subatomic particles. Hopefully, this is all review. In fact, most of this unit is mostly comprehensive and should be basic. Okay. So all atoms are made of 3 subatomic particles, and so when we talk about subatomic, it means exactly what it sounds like, below the atomic level. So you should know that everything is made of atoms, but all atoms are made of protons, neutrons, and electrons. Protons and neutrons make up the nucleus of the atom. That would be our little center right here. It's positively charged because neutrons have no charge, while electrons create an orbit, or a more accurate thing is a cloud. So now to take a closer look at those different particles we just spoke about, first up is protons. Protons, you need to understand, are positively charged. They're found in the nucleus. Like we said, that's the positively charged center of every atom. And each element has a specific number of them. So that means protons actually determine what element it is. It gives it its atomic identity, or its atomic number, and its overall name. If you change the protons, it's no longer that element. As far as mass goes, 1 proton equals 1 unified atomic mass unit, or AMU is what we call it for short, atomic mass units. Next up, neutrons. They have no charge, but their mass is considered equal to a proton. They're also found in the nucleus, but as we said, since they have no charge, they don't contribute to the positive negative effects of the atom. So we still say that the nucleus is positive. Also, 1U, or atomic mass unit, for the neutrons, because like we said, when we're judging the mass of the overall element, we consider them the same mass as a proton. Okay, atoms that have different numbers of neutrons, some of the same element anyway, meaning they have the same number of protons, would make something that is considered an isotope. If you've ever heard of something like carbon-14, carbon-14 is actually a radioactive isotope, and that just means that it's a carbon atom that has different amounts of neutrons. Okay. We'll look a little bit more at those, especially when we get to nuclear decay. All right, thirdly, we have electrons, usually symbolized with just a little E or a negative sign and a ball a lot of times. These are negatively charged. They are not in the nucleus. They're in outer orbits. In fact, there are orbital shelves that you'll find out that they're on. But the correct term to think about it, we love to see this symbol right here that shows all the little electrons circling because it makes it simpler for us, and we'll even learn a little bit later the Bohr model, which demonstrates the different orbital levels. Now, while they're all shelves, they move so fast and are so plentiful that it's considered more of a cloud. If you could actually get your eye to look on it, it would look more like a blurry cloud around the nucleus. They have nearly no mass, and so we go ahead and consider them massless. They would have one, it's hard to say, 1/2000th of an atomic mass unit. So it's so micro that we consider it to have no mass to the overall atom when we start to look at the element's atomic mass. All of our electrons are known for bonding. And if you gain or lose electrons, you have something that's considered an ion, which basically makes it negatively or positively charged. We'll look more at those in a little bit too. Last up on this video is what I call my cheat sheet. This is something I would make sure you have in your notes if it's at all confusing any of the things I just said. Go ahead and name what the atomic particle is, the charge that it has, the mass that it's considered having, where its location, and what it actually makes. So notice protons positive 1 AMU in the nucleus, and they make it an element. Neutrons, they're neutral, 1 atomic unit in the nucleus, they make isotopes. Electrons, they're negatively charged, we consider them a -1, protons a +1. They have 0 mass, they're in the outer shells, and it makes ions. And here's just a fun little picture of carbon for you.